Hello students, how are you? I hope you are doing well. Now I have again come with a video in continuation with the previous videos. We are discussing questions from 2022 Neet. So coming to question 36, a biconvex lens has radii of curvature 20 cm each of the refractive index of the material of the lens is, if the refractive index of the material of the lens is 1.5, the power of the lens is. Now in case of a biconvex lens, with radius of curvature R1 and R2 here, and assuming the refractive index of the material of the lens as mu, and of course we are assuming that the surrounding medium is air or vacuum. So we can write 1 by f is equal to mu minus 1 upon 1 by r1 minus 1 by r2. This is the actual formula where r1 and r2 have to be substituted with proper sign. So here r1 will be positive but r2 will be negative. So what is mu? Mu is 1.5. So 1.5 minus 1 is half. R1. R1 is 20 cm. Even R2 is also 20 cm. Remember, minus into minus will become plus here. So basically we got 1 by 20 cm. So focal length is 20 cm. This is clear. Now we require the power. So the power of the lens is 100 upon focal length in centimeter. You will get power in diopter. So this is the formula. So 100 by 20, that is 2 diopters. Third option is the correct option. Moving on to the next question, question 37. In a YDSE, a student observes 8 fringes in a certain segment of screen when a monochromatic light of 600 nanometer wavelength is used. If the wavelength of light is changed to 400 nanometer, then the number of fringes he would observe in the same region. Now students, we have to understand that the fringe width, that is the width or space occupied by each fringe, which is fringe width, is dependent on wavelength. So what happens when wavelength is reduced? Automatically the fringes will become narrow, that is fringe width reduces. We'll see as per the formula, fringe width is directly proportional to lambda. So if the fringe width reduces, now you can have more number of fringes in the same zone or in the same width of the screen. So let us try to understand with the help of a diagram. So this is the screen, let us say, and this is the central bright fringe. Okay, now suppose this is the width of the screen. Let us say you have 1, 2, 3, total n number of fringes. Okay, let each fringe width of each fringe be beta. So this entire length of the screen over which the fringes are present can be written as the total length of the screen is n times of beta, where n is the number of fringes, okay, appearing on the screen. So this length is constant. Now beta is lambda capital D by small d, which implies n into lambda is constant, because capital D and small d have been kept undisturbed. Then they have not been changed. So accordingly, initially we had number of fringes were 8 and the corresponding value of lambda was 600 nanometer. Whereas now what has happened? We want to know the new number of fringes when the wavelength has been changed to 400 nanometer. So automatically n will be 8 into 6 by 4. So 4 2s are 2 6s are 12. So correct option is second option, 12. Moving on to the next question. A light ray falls on a glass surface of refractive index √3 at an angle of incidence 60 degrees, the angle between the refracted and reflected rays. Now students, if you are aware of what is known as Brewster's law, it's a matter of few seconds. So let us discuss that, and then if you don't know Brewster's law, then we can proceed as usual with the usual method of the concepts of reflection and refraction. So first, using the concept of Brewster's law. Now Brewster's law states that whenever an an unpolarized light is incident at an angle equal to polarizing angle, then the reflected ray and refracted rays are at right angles. Reflected and refracted rays are at right angles. Now this polarizing angle is nothing but tan of what you call tan inverse of mu. Okay. Now here what is mu? Mu is root 3. So tan inverse of root 3 is 60 degree. As you can see, the angle of incidence is also 60 degree. So the reflected ray and refracted ray will be at right angle. So answer is 90 degree if you know this. But suppose you don't know the Brewster's law, then how to approach this? We'll be applying the usual concept of refraction. For example, you have this angle of incidence is 60 degree and you know the refractive index. Let us find the angle of refraction. Using Snell's law, this is air, is it? So 1 into sine 60 degree is equal to mu. Mu is root 3 into sine r. Sine 60 degree is root 3 by 2. So sine r will be half. In other words, r is 30 degrees because sine 30 degrees is half. Now we all know that the angle of reflection is same as angle of incidence. So this is the reflected ray. This is the refracted ray. We want to know the angle between them. We got small r as 30 degree. Now you see the angle contained in a straight line is 180 degrees. So from 180 you deduct 60 and 30 to get the required value. If I take this angle as alpha, if I take the required value as alpha, then I can write alpha as 180 degree minus 60 plus 30. So 60 plus 30 degrees is 90 degrees. So 180 degree minus 90 degrees is a 90 degrees. So this is the answer, first option. Then moving on to the next question. Question number 39. Match list 1 with list 2. You can see list 1 has some electromagnetic waves, different types of waves, whereas list 2 matches lists the corresponding wavelengths. Now, if I see the electromagnetic spectrum, students, roughly I'll write it. The shortest wavelength is of gamma rays. Gamma rays has shortest wavelength. Then you have X rays. Then you have UV, that is ultraviolet light. Then there is visible light. Then there is infrared radiation. Then there is microwaves. And finally you have radio waves. Radio waves itself can be categorized as short and long. So short and long radio waves. Okay. So normally approximately I'll write it is of the order of 10 to the power minus 13 to 10 power minus 15 meter X-rays, gamma rays. X-rays is in the range of 1 degree angstrom to 10 to the power minus 13 meter. Ultraviolet light from violet onwards. So violet has a wavelength of 4000 degree angstrom. So this will, you can take this as even 100 degree angstrom also. So from 4000 to 100 to 4000. Okay, 100 to 4000. Then visible light is from 4000 degree angstrom to 8000 degree angstrom. Infrared is below 8000, maybe it will go up till 0.1 mm maybe. So from 8000 degree angstrom to 0.1 mm. The microwaves, they are of the order of 1 mm to 1 centimeters. and this will be of the order of meters. Greater than meters, it can run up till several kilometers also. So short radio waves, they correspond to meters, and long correspond to kilometers, several kilometers. Clear? Radio is 10 to 100 meters this way. So now you can see out of these four, X-rays are the shortest. So just find out which is shortest wavelength, 10 power minus 10. So straight away match D with first. So D is matched with first. So all these three options are there. First option, third option, first option, third option, as well as this option, second option. Then next is, after X-rays you have infrared radiation. You can see infrared radiation is next. Next is 10 power minus 4. So C should be matched with 4. So C is matched with 4. Then microwaves, next to 10 power minus 2 you have 10 power minus 4 you have 10 power minus 2. So microwaves should be matched with 10 power minus 2. It is of the order of centimeter. B should be matched with 3. So B is matched with 3. And finally, the biggest of all is the radio waves, which is, you can see, they are of the order of 100 meters. So A should be matched with 2. So second option is the correct option. Now moving on to the next question. When light propagates through a material medium of relative permittivity epsilon r and relative permeability mu r, the velocity of light v is given by. C is the speed of light in vacuum. Alright. Now we all know that speed of light in vacuum is this, under root 1 by under root mu naught into epsilon 0. Whereas in general, velocity of light in any other medium is equal to the product of mu and epsilon, under root of this, for the medium. For now I'll write it as m. So for any medium, mu is written as mu r into mu 0. Similarly, epsilon is written as epsilon r into epsilon 0. So if I separate under root mu naught epsilon r to write this as C, then I will be writing this as C under root mu r epsilon r. Okay. So second option is the correct option. Moving to the next question, question 41. Two transparent media A and B are separated by plane boundary. The speed of light in those media are this and this. Critical angle for a ray of light. Critical angle is given by, we know the formula for sine of critical angle, isn't it? Yes. So sine of critical angle is refractive index of rarer medium upon refractive index of denser medium. Since mu varies inversely as speed of light, greater the speed, rarer will be the medium. So in that case I can write speed of light in denser upon speed of light in denser upon speed of light in rarer medium. So I'll denote the speed of light by C. So I'll write this CD upon CR. Speed of light in denser medium is given as, denser medium it will be less. So less speed means 1.5 into 10 power 8. 1.5 I'll write it as 3 by 2, 10 power 8. Whereas speed of light in rarer medium it will be more, that is 2 into 10 power 8. So we have 3 by 4, that is 0.75. Okay, 10 power 8 gets cancelled. So sine of C is this. So critical angle is sine inverse of 0.75. So sine inverse of 0.75 means fourth option is the correct option. That's all in this video, students. Thank you for watching my channel. Kindly subscribe to my channel and hit the like button.